Greetings, folks, and welcome to My Mind's Madness. In our last couple of videos, we've looked at what an IP address is and what a subnet mask is. Now we're going to have a look at how one impacts the other, specifically how a subnet mask has bearing on an IP address. I think it's key to remember that with an IP address, IP addressing simply defines a few things. It will tell you what the network address is, it'll tell you what the usable addresses are, and it'll also tell you what the broadcast address is. However, the thing that determines what these values are going to be is the subnet mask. The subnet mask tells us everything we need to know to be able to calculate these three values. So how does that work? The best way to look at it is in binary, first of all, using the likes of our 128 table. We're not actually going to be subnetting here. We're just going to understand how the subnet mask affects the IP address that we're given. Let's use an example and see how an IP address is impacted by a subnet mask. We're going to use the same IP that we used in our earlier videos, 192.168.0.1, and the subnet mask of 255.255.255.0. We're going to do a different subnet mask value later. For now, we're just going to look at this /24. We call it a /24 because when we look at the binary of the subnet mask, it's going to be 24 ones. And that then gives us this slash number 24, which is actually the CIDR, classless interdomain routing number. What we have to do is we're going to draw the IP address and the subnet mask on top of each other in their binary form. The reason for drawing these out directly on top of each other is that each binary bit in the subnet mask directly impacts the binary bit above it of the IP address. So to give you an example, this binary bit here directly impacts what we can do with this binary bit here. Same thing goes along the entire board until you get right to the end where this binary bit impacts what I can do with this binary bit. And how does that work? Well, where we have ones in the subnet mask, the mask is going to lock out any of the binary bits. Where we have zeros in the mask, it's going to open up or unlock those bits. Where we have all ones in the subnet mask, I want you to follow them and then draw the line directly up where they end and the zeros begin. This is the network portion. What's interesting about the networking portion is that all of these binary bits and their corresponding bits are locked out to you. You can't touch any of these pieces anymore because they have the one in the subnet mask. So all of the entire network portion is locked out to you. You cannot do a thing with it. Where the zeros begin though, this is what we call the host portion. What we can do with the unlocked portions, we can manipulate any of the corresponding bits. So where we have a 0, we could change this bit to either be a 0 or a 1. And we can do that for all 8 bits. This gives us quite a lot of power within these 8 bits. But how does this help us? We can now start to calculate NFLB, the network, first usable, last usable, and broadcast address. How do we do this? Well, to start off with, we are going to take the all ones and we're going to calculate what they read. And that's going to give us our network portion. Now, because the network portion lets us know like these first few octets, and we've got this definitive boundary octet where the ones stop and the zeros begin, this is always going to be 192.168.0. something. We can do the same for all the rest of these here just now. Now, how do we figure out the rest of this? Well, the first thing we want to do is actually calculate the minimum value that we can create. Now, to create the minimum value, we want to take all of these binary bits in the IP address and turn them to their lowest value. There's only two values, 1 and 0, so we just want to turn them all to 0. So the minimum value is 1, 2, 3, 4, 5, 6, 7, 8 zeros, which equals 0 in decimals perspective. And because we've calculated the minimum value, that's actually our network address. Next, what we're going to do is we're going to calculate the maximum value. And that is where we take all the available bits, the same ones, and we're going to max them out. We're going to turn them all into ones. So that is 8 ones. That equals 255. That is our broadcast address. Now, calculating the first and last usable is very easy. All we actually need to do is add 1 onto the network address and subtract 1 from the broadcast address. So first usable will be 192.168.0.1 and the last usable will be 192.168.0.254. And now we have our entire network and we know the range that it spans thanks to the subnet mask. Let's use the same example of IP range, but we're going to change the subnet mask ever so slightly to give us a different outcome. So in this example, we are going to change our subnet mask value to be 255.255.255.192. And that's going to change our subnet mask to read 11000000. Now let's do exactly the same logic. We're going to take what is our host portion in red. Now that goes all the way into the 4th octet this time. So this is our, network portion. And that is locked out to us. We can't touch those bits. They are locked. And now we're going to have a look at the host portion. And these are our unlocked bits. Using this, we can calculate the same things. We want to be able to calculate the minimum address that we can create and the maximum address, which will help us determine the network and broadcast addresses. This is where it gets a little tricky. We have to understand what's happening with our subnet mask here as well. And these 2 extra bits that are being played around with here, these 2 extra bits that have been locked out, they're going to change significantly what our min and max values are. Well, certainly what our maximum value. We know we have 192.168.0. And now we are going to calculate the minimum and maximum value that we can create with 1, 2, 3, 4, 5, 6 bits. So 1, 2, 3, 4, 5, 6 equals 0. No surprise there. So our network address in this instance is .0. What's the maximum that we can make here with only 6 bits? 1, 2, 3, 4, 5, 6. Now, you may need to go back to your 128 table, but just to kind of refresh your memory ever so slightly, this is 1, 2, 4, 8, 16, 32. All these bits have been turned on. So the next one after that would have been this one here, which would have been worth 64, but we can't use that. So we know that this is going to be 63 because that's all these values added together. So our broadcast in this instance is 63. Interesting. To calculate the first and last usable, we just use the same logic, +1, -1. So the first usable is .1 and the last usable is .62. Really nice and easy. One thing I also want to take the time to point out right now is that there's a special rule when you're calculating NFLB. This one will always be an even number. And I'm not having the argument that 0 is neither even or odd. It's an even number. This number, the first usable, will always be an odd number. This number will always be even. And this number will always be odd. This is a rule that persists all the time. If you calculate a broadcast number to be an even number, you're wrong. I'm sorry, that's it. So let's go a little bit more crazy now. We're actually going to go into the 3rd octet and understand how taking a single binary bit from the 3rd octet, this one right here, is going to impact the size of this network. So let's take a second, wipe this board, and figure it out. And we're back. And in this instance, we have decided we're going to create a subnet mask of a /23. That's where this single 0 has been added right at the tail end of the third octet. And I say added, we've just borrowed that bit into the host portion. Let's make our navigation. So our network portion now goes here. And our host portion goes from here. It's not a massive jump, but it's going to make a big difference. So what can we do here with this network and host portion? Firstly, let's start writing down our network first, last, and broadcast. We know probably straight off the bat at this point that our network address is going to be 192.168.0. something, 192.168.0. And the minimum value that we can create with this 9 zeros is 0.1, 2, 3, 4, 5, 6, 7, 8. So that means we can create a value of 0 and, because this is in a different octet, 0. So we've got 2 zeros there. So that's our most minimal value that we can create. Next, we're going to go and create our maximum value, which is going to impact what our broadcast address is going to be. Now here, we can manipulate this binary bit here. So that means we can set this value to 1 dot, and then we can set all the rest to 1 as well. 1, 2, 3, 4, 1, 2, 3, 4. Now this means that my values can be .1, and then 2, 5, 5. That's the maximum value I can create with these values. So my actual mask address here, or my broadcast address, is going to be 192.168.1.255. And there we have how my subnet mask, there's that one bit, has actually changed where my kind of lockout happens, okay? Still the same bits that are locked out. It's just that this one extra bit means that I can manipulate part of that third octet. Finally, to calculate the first and last, so we add 1 onto this and we subtract 1 from this. So that's going to be 192.168.1. And this one I'm going to write out 192.168.1.254. That is the last usable address that we can have in this space. And there we have it, folks. That's how IP addresses are impacted by subnet masks. Hopefully you've taken a lot out of this one, and now you're going to be ready to learn subnetting.